and welcome to, I guess I'll call this Demo Day with Splat. Brett Taylor coming to you live, talking about cloud deployment options today for Superalgos and how the demo.superalgos.org website is now configured and running. So I guess a couple of options, a couple of things to get out of the way first. Superalgos itself right now is currently not really designed to be run outside of a local network. It's not designed to be exposed to the internet. It doesn't have any security built into it. Anything that you do, you need to configure your own security around it. Typical security things are passwords, which is authentication, and securing the pipe, securing the transit of the data. So typically with a website, you would be running HTTPS. You would be using SSL or preferably TLS. If you have to run Superalgos, the best thing to do is to just run it privately on your own network. If you have to run it in the cloud, you'd potentially, the easiest way to do that would be with a VPN, which is what I walked through a couple of videos ago, setting up a cluster in AWS with OpenVPN. I tried and I failed, and I since figured it out again what I was missing. But you can use a SSH tunnel to access your Superalgos cluster or machine. The options you want to be looking for are local forwarding. So you can send both the WebSocket port and the web front-end port to your local machine when you connect over SSH. And it's also possible to do with X11 forwarding, where you have essentially a browser that is running on the remote host, but is being presented on your local machine. A couple of other options, and this may not be fully exhaustive, but this was just what I came up with in the first couple of minutes before this video started. And I guess I should also say, I apologize. I think I may be coming down with a cold. Both my kids were sick earlier this week, and I feel like I may be coming down with it. But anyway, if you're going to be running public, having it connected to a public IP running on the internet, you basically need some type of encryption, and you need some type of authentication. Typically, you'd use something like Nginx, a reverse proxy, to terminate TLS, and then maybe something simple like HTTP auth, or that you would use HTTpassword to create your username and password. Nginx would do a simple check and then let you on or not. This is not, as far as I'm concerned, not fully available as an option currently because it works very well for the web front end, but there isn't a way to present that authentication on the WebSocket port. So a better option would be mutual TLS, mTLS, where you create your own certificate authority and you tell both the remote server and your local server that you trust each other, and essentially authenticate that way and create your totally blanked out. You create your encrypted tunnel using the certificates that you create and you sign yourself. the way that we are running the demo website is we're kind of doing this public with TLS and auth, but we took away a lot of the options that you would be able to do running it yourself. So you can't save a workspace. So typing in your API keys that would allow you to trade live on an exchange, you could do it in the current instance that you're running, but as soon as you close your browser, refresh your browser, that would be gone. So that prevents somebody else from being able to see your keys if you happen to type them in. It also kind of prevents us from hopefully having somebody for free start using the server that we set up to start trading. The other thing that we did with the demo mode is we turned off the ability to excuse me, to run tasks. So even if you did put in your credentials, you can't kick off trading tasks, you can't kick off data tasks. So you're essentially limited to a read-only session of what is on the server at the time, which is just some Binance BTC USDT data. And the trading session that I ran, that's basically a part of the tutorial that you'll get to walk through if you start up the website. So that's just a very high level overview. I'll go into a couple of details here, and I'll probably walk through exactly what I have set up. Excuse me. And I guess I never talked about my beer introduction here. So today, I've got another tire in hands. I'm drinking Only Void, which is a special stout that they released a couple weeks ago. It's an imperial stout. This one has the chocolate, graham cracker, and marshmallow. It's the s'more version, s'more variation, and it's extremely dark and dense and sweet, and excellent as a dessert beer. Very nice on cold winter days or cold fall days. I'm a big fan. So cheers. I was able to get the crushable Only Void, the OV. It has a much lower alcohol content. And then I also got the regular Only Void, which is Imperial Stout, but it doesn't have any fancy chocolate or coffee beans or anything like that in it. It's also pretty good, but I definitely I don't get a lot of I guess graham cracker and marshmallow out of this, but I do get a lot of chocolate flavor. It's very tasty. Anyway, I was gonna drop a quick sketch here of what we're kind of looking at. Let me I don't need to zoom in that way. Zoom in this way. So let's say we have our client. Your typical web server, you would make a request on port 80, HTTP. Let's call this our web server. And then it would just basically essentially send data right back to you. Completely open, no encryption. Just, you know, your standard web application. So when you do HTTPS, this then becomes port 443 by standard. Did I type that correct? 443. And this would be either SSL or TLS, and currently TLS is the most preferred, and I believe it's 1.2 or newer. 1.3, I think, if I remember correctly, is the newest one. Not everything supports 1.3, but if you can run 1.3, you should. As a client, you don't necessarily have to worry about that, but you can usually go up to and see this lock, if you can see where I'm hovering my mouse at the top here. At the top by your web address, you should be able to make sure that your connection is secure, view your certificate, and I thought that they might show you if you are connected via TLS or not, but maybe Brave doesn't do it. But there are other ways to do it. Let's see, I think there's OpenSSH S client. If you want to do a quick Google search, you can check your ciphers and how you're connected. And I guess I can do this real quick because I do have a browser, SSH session open. So look, you can see we are connected at TLS version 1.3, and we're using a TLS AES 256 SHA 384 cipher, and you get your certificate. So you know that your connection to Google, in this case, is secure. And let's do the same thing for just the regular Superalgos.org website. It is secure using TLS 1.3 and the same cipher. And we can do it for demo. Let's see what we get. Same thing. We're using a Let's Encrypt. I just got this set up right before I started the video. And we're using AES 256 SHA 384. So the web front end, at the very least, right now is encrypted. So that's how that works. In the event of having Superalgos with a WebSocket, though, it's a little bit different. We have a second pipe that you need to, or a second channel that you need to secure. And this one is the WebSocket on 18014. I think that was the port. Let's see here. 18041 is the default for Superalgos. And this right now is not encrypted on the demo superalgos.org website. The reason being the configuration between the web server and the client application, and what the web server is listening on. And then we also have Nginx to worry about. You can have more than one thing on the server listening on the same port. So right now, Nginx is listening on 443. The Superalgos client, or sorry, the Superalgos web front end is listening to 34248. So what our reverse proxy does is it takes your client, sends it to 443. Oh, this isn't going to work, is it? And then it proxies your request over to 34248. And really your response is coming back essentially from that port. If you were running this yourself, you should be able to configure Superalgos to listen on, let's say, 1842, and then also set up a proxy port on, say, 18041. Have your client talk to 18041, proxy the port over here. So this would be Nginx proxy. Oh, that got disgusting. There we go. A little bit bigger there. Let's do this. Come on. This graph is turning out. So this is kind of like what we want. And this would be all TLS on this side. And then Nginx would essentially terminate the TLS. Excuse me. And then on this side, this would be unencrypted. But this would be okay because it's not really leaving the internal network on this side. So if we put this up here to kind of signify that. So Nginx is kind of acting like a bouncer, if you will. And it's allowing traffic in and out, making sure it's secure on one side. And then once you're inside, it's not necessarily secure. But at this point, you need to make sure that you have your server or your network secure as much as possible. And essentially, as far as Superalgos is concerned, you are talking to it on the local network. It doesn't know any different. So that's, I guess, ideal case, if you will. And then with mTLS, I guess this would kind of be the mTLS part. You also get this private CA, which is creating these TLS certificates and essentially saying, giving an identity to this client and giving an identity to the server, Superalgos, and the private CA is what's saying, yes, you can trust that. I pulled up one, just did a quick search for a mutual TLS. First one was this Cloudflare document. If you want to do some further searching, you can just search for Nginx TLS. I think this was one of the first items in the search that came up. And I just did a quick look through. Looks like it has some pretty good information. I have not followed all the way through it. But maybe in another video, I'll actually go through, follow one of these tutorials, and walk you all through it so you can see exactly how to do the same thing. But the information is out there already if you need it. So let's go ahead and close this out. And I will show you a couple of things that I set up for when I was trying to decide how exactly to run this demo.superalgos.org website. Let's see. So I set up a what is this? Superalgos demo CDK. Yep, here it is. So I'm very used to running things in AWS for work, and I've used Terraform before. I'm currently using mostly Cloudformation, and AWS released essentially a wrapper for Cloudformation called CDK, which is like a Cloudformation developer kit. You can use a couple of different languages. TypeScript was the very first that they released. And since Superalgos is written in Node.js, TypeScript or the JavaScript versions make perfect sense to continue on with that line of language. So I haven't used CDK a whole lot in my work. I thought this would be a pretty cool project to get me a little bit more familiar with it. And it was actually pretty easy. AWS has a lot of documentation around it. So they have this big API reference, it has all kinds of different support. One thing I have learned at work is that Cloudformation does not 100% support the AWS API, and CDK does not support 100% Cloudformation. So your mileage may vary. They are pretty good at keeping them up to date, but they are not 100%. And I believe they have GitHub repos. /AWS. And they have some projects. Let's see. They do have a CDK roadmap that you can follow, see what's being worked on, what has been released recently. There is an AWS ECS roadmap. The containers roadmap. And excuse me. Same thing. And I think that some of their other projects have similar things, but the reason I came here to the ECS roadmap is I thought it would be super easy to not have to worry about the security of the server, keeping it up to date with patches, making sure that it's highly available, things like that, by running it in AWS Fargate, which is an ECS product. So I created this CDK repo to very quickly stand up a load balancer with a container behind it, and all of the infrastructure, all the other background infrastructure like the VPC, subnets, NAT devices, internet gateways, IAM privileges and restrictions, subnet groups. Sorry, did I say that already? Probably did. What else? The security groups to secure this. ECS will take care of the scheduling. If I say I want one container running, it will always make sure that I have one container running. If it happens to land on a bad server or a server goes down for maintenance, it will just automatically restart it for me and make sure that I have one going. The downside of this is you pay for that convenience, and it's a lot more expensive. Whoops. So this solution ended up costing, I think it was about an estimate of about $40 a month, which is pretty expensive to run a single container. But how much is your time worth? My time? I don't know. I might have been able to say that it was worth it. But I'll just say what I ended up doing was dropping back to running a $5 DigitalOcean virtual machine. And it's much cheaper. They do a pretty good job of making sure that it's always up and available. Downside would be if I have to recreate it, the IP changes. I'll have to make sure the DNS is updated and match. I may have to worry about backups if I'm running a single container in Fargate. No backups needed. It's a container. It just does it. But anyway, long story short, the CDK was extremely easy to work with. I actually enjoyed it. Enjoyed learning about it. It is a little bit verbose, but it is not as verbose as writing out YAML or JSON CloudFormation by hand. So, first thing you do when you're starting a brand new CDK project, you type CDK init, and it sets up this whole like skeleton of a directory for you. Then I'll let you go through AWS docs. Oh, takes me to the same place. Let's see. To the developer guide. They have examples, they have best practices, but their examples are pretty good. How to get started, setting up your first app, do CDK init. You can npm run build if you need to. You don't necessarily have to. Install your CDK, AWS Essentials. You can synth to get CloudFormation itself, but basically you just need to CDK deploy, if you can see that. So once you CDK init and install your packages, you look in your lib, you have your TypeScript file here. You do your imports. You need to make sure you have these packages like AWS EC2, AWS ECS, load balancing, IAM, logs, Elastic Load Balancing v2. Oh, I guess we got that imported twice. Oh, specific things. I set up these constants because I was using these ports in a couple different places. Wanted to make sure they were the same, but we set up a VPC. We make an ECS cluster, set up our security groups, configure a couple of rules for the security groups, saying allow ingress on the 2 ports that we need. Set up a log group for CloudWatch logs. using the AWS log driver, which is CloudWatch. Make an execution role. This basically just says that your task is allowed to run itself. You can add more rules to this, like if you have private ECR repos, you need to give your task the ability to pull from that private ECR repo. If you want it to be able to read from Secrets Manager or something like that, you need to give it IAM privileges to be able to read what it needs to read. Contacting RDS, contacting DynamoDB, whatever else you need, that goes in the task role. Excuse me. Then we set up our task definition. And here's where you set your CPU and memory limits. Fargate has specific pairs that you can use that are valid. This essentially says I want half a CPU. One CPU is 1024. 1 gig of memory is 1024. So this was trying to keep costs down. In AWS Fargate, the memory is what'll get you. CPU is not that expensive. But when you go from 2 1 core, I think the minimum is 2 gigs of RAM. If you go up to 2 cores, minimum is 4 gigs of RAM. And I think 4 cores may be the maximum in Fargate. And I think the minimum there is 8 gigs of RAM, if I remember correctly. But make sure you check out the pricing if you're setting this up. And I think the maximum amount of RAM that you can use is 32 gigs. So if you need more than 4 cores and 32 gigs of RAM, then you'll probably want to do regular ECS or EKS or run it yourself. Run your own Kubernetes or Docker Swarm cluster if Docker Swarm is still a thing. Then we set up our containers that are a part of the task definition. We only have one in this case. It's the Superalgos container. And here we were setting it to be no browser is the default, and these extra settings of min memory and demo mode. And then we also had to set a couple of environment variables to fully configure demo mode, setting it to true and setting the host to the IP or DNS of the server. And then we had to, in the container, set the port mappings for the web port and the socket port. And then once you do that, you set up an ECS Fargate service, tell it to use the cluster and the task definition we made before. It's not going to get a public IP because we're going to use a load balancer out in front of it. And the main reason to do that is because if you set this to true, every single container will get a different public IP. So unless you have automation set up, possibly in CDK, to configure your DNS to specifically point to this one container, like if you are using Route 53, totally doable. You don't need a network load balancer for a single container necessarily. But in our case, the domain name is not inside of AWS. It's not configurable by Route 53 and by CDK. So the load balancer was necessary to keep a single IP no matter what container is running. So here's our load balancer. The reason I went with a network load balancer is that I only needed to forward ports. I didn't need to forward paths or endpoints. So otherwise I would have used the application load balancer in a typical web app setting. But here we have the internet facing true. So the network load balancer gets a public IP. It could potentially terminate TLS. And then our server is attached to that load balancer using target groups and using these listeners. So the target groups are what actually have this service. It's more or less kind of the backside of the proxy. So your listeners are kind of the front end, where on our, I closed it. But on our current setup, Nginx is listening on port 443 and port 80. But the web application is listening on 34.248 and 18.041. So our listener in this case would be port 80 and 443. And the target groups would be the 34.2480. 34248 and 18.041. And that's essentially it for the setup. And then once you have this all configured, you take this file, go back to your main directory if you're running on your console, and you essentially just type CDK deploy. You have to have your access keys for AWS set up. It will create a Cloudformation Stack for you, and it'll set up all these things in AWS for you automatically. Any changes you make will be reflected in the Cloudformation and applied for you automatically. Cloudformation has a couple of neat things built into it where it has automatic rollback if something fails. The default is that it stands up new things first before it deletes old things. So it will apply your brand new changes and then it will go up and clean up after. So very easy. If you want an example of how to stand up Superalgos, not securely, might I say, unless you're running demo mode. But if you want an example of how to stand up Superalgos in Fargate, this is one way to do it. Again, the reason why we chose to move off of this is cost. So what I ended up doing was going over to DigitalOcean. I reached out to them first to see if they had any credits available for open source projects or just general, brand new developer trying to test it out. And they unfortunately didn't. I think they do have, general marketing codes that you can apply every once in a while to get it like a month or 2 months of credit. But they weren't able to. Some projects, if you have a nonprofit, they will definitely be able to help you out. But for us, I guess we didn't match the criteria. So what we ended up doing is using a traditional droplet virtual machine, running with a regular Intel SSD, doing $5 a month, 1 gig, 1 gig of RAM, 1 CPU. I would not use this for a production setup. You could totally use this to run the private network with an SSH tunnel option. I would jump up to the 2 CPU and 4 gigabyte if you're going to do a cloud deployment. 1 gig and 1 CPU not really going to be very useful, and you'll probably get very upset with how slow it is very quickly. But if you were setting this up yourself securely in DigitalOcean, you'd essentially be using one of these options here, connecting to it with a VPN or using an SSH tunnel with the local forward option or X11 forwarding. I would try to go for the local forward option because generally I don't like to install X11 graphical things on a server. But if that's more your speed, you can do that. So that's probably going to cost you about $20 a month per node. Excuse me. And that would kind of equate to running a Raspberry Pi in your house. But consider that a single Raspberry Pi board at about those same specs. Let's just look this up real quick. Let's look up the Raspberry Pi Model 4. If you want the 4 gig option, let's just go look at the Pi Hut. That's 54, was that pounds? Let's look at United States because that's where I am. Let's go to Adafruit. $30 for the 1 gig board, $55 for the 4 gig board. I think this is 4 cores too, so you get a little bit better. But essentially, you know, as soon as you get to 2 or 3 months, you might as well have just bought a Raspberry Pi and ran it in your house. But if you want cloud, you know, maybe your internet isn't so good, your power isn't so good, running it in the cloud is a more stable option. So maybe that's more your speed. But let's hop on to our node here. Take a look. So I'm on our DigitalOcean host. Hey, there you go. We've got 1 core and we've got 1 gig of RAM. We're running a whole bunch of stuff. I essentially followed the README in Superalgos to install what I needed, but I am running it as a Docker container. You can see here, I guess you may not be able to see. Could I zoom in? I have to change the text. I do not enjoy using putty. Much rather be on a Linux box or a Mac. What am I looking for? Appearance. Change the font. Let's make it 14. Is that easier to see? A little bit. So I am using Docker. This Linux server swag is the Nginx front end that I'm running to terminate TLS and the reverse proxy. And then we have our Superalgos, which was running latest as of 2 days ago with our demo mode enabled. So let's see. So the way that I started doing this is I pulled the code, git cloned. I do have Node.js installed on here. 17.1, which is the latest. I do have Git installed. Essentially, just followed the GitHub guide here. README. Python's installed. It's 3.8, 3.9, something is the latest, but this is what Debian or Ubuntu gives me. And what else? Docker version. We're on Docker 2010. So there's a whole bunch of information if you're trying to, find out what versions we're running and hack us. Cool. I did make a couple of small modifications to the code. I set up those environment variables instead of setting them as hard-coded variables. And I have this branch pushed up to my own fork. But essentially, I hard-coded our IP, which you can get if you DNS lookup. So that's not necessarily secret. I set up our two environment variables. And we have our data mounted from the local file system. To get that data, the demo mode does allow, if you want to run demo mode yourself for whatever reason, demo mode or set up your own, demo cluster, whatever. Demo mode does allow you to run the tasks if you are on the local host. So in order to do that, I tried to do it with a local forward and an SSH tunnel. It would not let me do it. You would have to possibly do the X11 forwarding if you're running an Linux box, or remote desktop if you're running Windows. But what I ended up doing is just running the data mine locally on my own local install version of Superalgos, and then I used rsync to copy the data up. And the same thing for the trading backtest to get the data working. Let that load. Hopefully it loads in the background. Yep. So you can see when you load up demo mode, you got this really nice "You are in demo mode" banner at the top. You can go through and do the tutorials, but you can see when you try to go to a data task, it says, "Sorry, you're in demo mode, you can't run the task." If I try to do a trading task, same thing. If I wanted to run production, same thing. Won't let me do it. If you wanted to, you could absolutely. This code editor, by the way, is new within the last week or two, and it is pretty awesome. So kudos to, I can't remember the name of the user that did this, but it's pretty awesome that they did it. And I will make sure that I figure out their name and give them proper a proper shout out next time. Sorry. So if I wanted to say like, this is my key. Oh, code name. I don't think I wanted code name. It's code name. Code name. That doesn't seem right. Anyway, this is my key. And this is my secret. When I save, it's saved here. But when I try and save the workspace, I can't save. It's not doing anything. So if I refresh, and I go back over there to the Exchange account key, you'll see that my changes were not saved. So that is the cool thing about demo mode. It is purely read-only. So when you're running Superalgos yourself, these workspaces actually get saved on the server. They are running in your local computer, your local client. Your local client will preserve which workspace you had loaded last time you loaded that website or host. But you can also see that we have, so if I had saved a custom workspace, it would be purple at the bottom down here. These are all the included workspaces. So now you can also go and look at the token distribution if you want. See how it loads. Excuse me. Oh, I should have shown you the chart space. Anyway, we'll get back. Excuse me. We'll get back to that. And maybe this will load. Let's see how our server's doing. I got failed to ban running. I haven't checked to see if it's banned anybody, but hopefully that'll keep people from trying to SSH in. Still loading. Sorry, I was hoping it would load. Maybe not. Maybe it ran out of memory. Hello world tutorial. Does this one load? I didn't even try anything else other than the getting started guide. I don't know. Did I break it? Maybe I did. Maybe I can't even change workspaces. Yeah, getting started guide works. Loads fine. I don't know. I didn't try loading any of the other workspaces. Guess not. I don't know. So I think that's it. I don't know if I have anything else to talk about. Oh, I didn't walk through swag. So the first thing I set up was I literally just got Superalgos working. So connecting to port 34 2480, 24.8, as you would if you were running this locally. And then I thought that looked ugly. You know, you want to just connect to demo.superalgos.org and run it. So I set up a simple Nginx proxy that essentially was just listening on port 80 and forwarding you to the app server, which is the local IP and port 34248. And then a couple people mentioned that they were getting insecure website and that, you know, looks bad every once in a while, even though in theory you have nothing to worry about because you aren't sending any credentials, you're not sending any API keys, you're not sending anything that is data that you wouldn't want somebody to listen to. And you're essentially connecting to a public website anyway that doesn't have any of your private information in it. You shouldn't be sending private information to it. So really, listening on port 80 unencrypted should be totally fine. But I get it. Some like Chrome and other web browsers are trying to make the world a better place and force everybody to use HTTPS. And with things like Let's Encrypt, where it's free to do so, to get a TLS cert, SSL cert, might as well go ahead and do that. So there is a project out there called linuxserver.io, and they provide a swag container, which is a, let's see what they call it. What is it? Secure Web Application Gateway. I think that's what SWAG stands for. But Linux Server provides a bunch of different Docker images for a whole bunch of different apps. They used to call it Linux Server Let's Encrypt, and then they turned it into SWAG. But it essentially has Let's Encrypt inside of it, so that you can get a free, the cert bot, you can get a free certificate for your server. And since it's free, there's no reason why we shouldn't be using it, right? So I started a branch to try and do this for my own local running Superalgos. And then I found out that couldn't really secure the web socket port very well without the mTLS, because there's no other type of authentication in Superalgos. So I kind of gave up. I do have a branch out and running it, or up in GitHub if you want to look at it. Its branch is called Swag, I think, or Add Swag. But what I did was take that configuration and Docker Compose and put it up here. Made a couple of small modifications to it. But you essentially just have to put in the PGID and PUID are what map the internal user in the container to your external user on the main file system. You can put in your email. I don't think it's necessary to do so. The URL is the obvious URL host name of the server that you're trying to create a certificate for. Your time zone, I'm in America, New York. And the validation over HTTP, I think that there's a couple other options, but this basically just says that it's going to put a specific text file that Let's Encrypt tries to pull to validate that you do own the domain that you are creating a certificate for, or attempting to create a certificate for. And that just pulls straight from this container, this Nginx instance. We mount our configuration directory, we map our directories, and we tell it to always restart unless we have stopped it ourselves. The added privileges here, netadmin. I can't remember exactly why it needs netadmin. It might have something to do with the authentication attaching to port 80. I can't remember exactly. But there isn't anything. Oh, so this is a whole bunch of stuff that the container writes out. Since this is a persistent volume on the local host now. One of the interesting things is that you do have the keys here. So if the container starts and stops, it'll pull the same key, and that's good so that it doesn't overload Linux Let's Encrypt by trying to make new keys when it doesn't need to. The container will take care of renewing the key on its own automatically, which is pretty cool. But we need to look in our I'm blanking. Nginx. If you want to add extra Nginx settings, it does have the Nginx conf here now. It writes it out to the file system for you. And it is persistent on disk. I did not mean to say that. So if you want to change any of these files, they will persist into any new container that comes up. So if we cat the default Nginx conf, I didn't make any changes to this, but you can go ahead and set the user if you need to, where to write the logs, how many worker connections, things like that. Anything else you might want to do. If you go into conf.d, where is it? Siteconfs. I wrote this default.conf, and this is what's serving up our HTTPS front end. So we have our typical redirect 301 from 80 to 443. We set up our app server saying that our backend is our Superalgos server. Include all the fancy SSL settings that they write out themselves. We do support HTTP2, because why not? Include all of the fancy proxy settings that they write out, that they include in the container. And then we basically just proxy pass to Superalgos. Not too fancy. So if you want to get this going yourself, it's relatively easy. I don't know. I think that's it. I don't know if anybody else has any other questions. I guess one thing to note, somebody was asking about in the channels earlier in Telegram, is why is Superalgos itself not encrypted? And why can we not connect over SSL? I think somebody... Yeah. Somebody made a PR a couple weeks ago to be able to enable the mutual TLS and to tell the front end to connect over a secure socket. And now I am trying to figure out exactly where. Excuse me. So yeah, I think that these are the settings now. So if you go into, of course, this didn't load. The getting started tutorials. And hopefully this loads. Let me just refresh. So I believe, let me go down to the network node. I believe that this is where you can set that WebSockets external URL. I think that's where you configure it to be WS or WSS. Ah, yes. So the WS itself, in this context, is not secure. And then if you do want to use secure, you can set your WSS // So I think you could set this WebSockets external URL if you were to do this yourself. You could set something like localhost 18041. And I think this part of the code, where is it? This part of the code is what will allow you to set a secure socket when you're setting up your mutual TLS. But of course I can't do that on the demo site because I can't save it. Anyway, no questions tonight popped up in the chat. I don't think anybody else is watching. So I'm gonna sign off, call it a night. If you have any other questions, find me in the Telegram chat. My name is Splat and Brett Taylor. You should see me there. Open up issues. Feel free to open up issues on the Superalgos project in GitHub. We have started splitting out into different teams and projects to be able to scale better and address issues. Oh, and it doesn't like. Interesting. I wonder if it actually accepted that setting that I put in. Anyway. So find me on Telegram, find me on Discord, open up issues on GitHub. Feel free to contribute, make a PR. If you want some guidance, again, feel free to talk to us in Telegram. Join the Reddit group. I try to keep that updated with things. Not too many people are talking or posting their own things in there, but at least we have a whole bunch of information in there. Facebook and Twitter, Superalgos. Mine is splat_algo. Follow me. Keep up to date with what I'll be presenting next. And that's pretty much it. I'll try and get this video up on YouTube tomorrow, so you can watch it again if you want, or refer other people to it. And other than that, I'll be back here again next week. Catch you on the flippy floppy. Have a good one.